For our second problem of converting a polar coordinate to our rectangular coordinate, your r theta to an xy, I actually threw in 5 pi 6 as a rating. That should not throw us. It's not that big of a deal. We'll just have to convert this to degrees, or if we know what it is, we can go straight from there. So again, how I like to do this, let's just go, your x coordinate will be r cosine theta. Y coordinate is r sine theta. And then just fill in the details. Of course, this is our r, this is our theta. So we're going with -4 times the cosine of 5 pi 6. We're going with -4 times the sine of 5 pi 6. Like I said, I like to do this, put these horizontally because of the fact that I just take this one step simpler each time, and we can do them simultaneously. All right, 5 pi 6, you should know, is 150 degrees. All right, so we can take our next step and actually write that out, and it's probably not a terrible idea, especially when we're first doing these, just to see every step in gory detail. So it's -4 cosine 150, -4 sine of 150. All right, now 150 is a little bit large. It does have a reference angle. So I'm going to draw that. I'm not drawing the polar plane. This is an angle in standard position. 150 degrees. Here's my initial side. Counterclockwise 150 gives me a reference of 30 degrees. In quadrant 2, super important. Both the reference angle and the quadrant you're located in. So I'm going to rewrite these. It's -4 times the cosine of 150. Well, the cosine of 150 is no different than the cosine of 30, except for the fact that you're in quadrant 2, where cosine is definitely negative. That's important. All right, so maybe you might want to make note. That's because of Q2. You're in quadrant 2, cosine is negative. And then we could do the same thing for sine. What is the sine of 150? Well, it's no different than the sine of its reference angle, 30, except you're in quadrant 2. But in quadrant 2, sine is actually positive, so the sine of 150 is exactly the same thing as the sine of 30, because sine is positive in quadrant 2, as it is in quadrant 1. All right, so next, let's find the exact values of these. So I have a -4. The cosine of 30 is the square root of 3 over 2, but don't forget that negative in front. Over here, sine of 30 is 1/2. Multiply. We have -4 times negative square root of 3 over 2. 2 goes into 4 twice. The negatives cancel. Looks like it's 2 square root of 3. -4 times 1/2 is -2. Mystery solved. What is -4, 5 pi 6 in rectangular? Well, the x-coordinate is 2 square root of 3. The y-coordinate is -2. X-coordinate, y-coordinate. That's the conversion. Right? So this point we know is a quadrant 4 point. If you plot this, you will see, lining it up with the Cartesian coordinate system, that does show a quadrant 4. I hesitate to do this, but let me try it. All right, -4, 5 pi 6. I'm going to try to plot polar, freehand. It's very dangerous. I don't recommend it. So -4, that's 4 to the left of the polar axis. I'm really drawing the polar axis. Then I have to go 150 degrees in the counterclockwise fashion. So I'm talking about a circle of radius 4. I don't know how good that looks. And 150 degrees would be right about there. And yeah, you can see that this is definitely a quadrant 4 point if you go back to the x and y axis. And what is its x-coordinate? Well, its x-coordinate is 2 times the square root of 3 over. Its y-coordinate is 2 down. That's the idea. That's the relationship between the polar and the rectangular plane. All right, let's try to hit a couple more examples here. So, like I said, the hardest part of these is really the conversion. When you go to, not the conversion, the finding the exact value. Those are always the biggest pain. All right, so let's see a third example here. We got a decent one. Let's go with -6 negative pi force. -6 negative pi force. All right. Let's convert that to rectangular. Now, real quickly, let me kind of do what I did at the end of the last problem. Let's kind of gather what quadrant this might be in. So when I look at my answers, at least the x and the y coordinates should have the correct positive or negative signs. So if I try to plot this on the polar plane, it would be 1, 2, 3, 4, 5, 6. So there's -6. And that doesn't look like an egg. Negative pi force, that would be 45 degrees in the clockwise fashion. So 45 degrees. We'll be looking right about there. Now go back and focus in on the Cartesian coordinate system. I'm asking, what is the x coordinate? What is the y coordinate? Well, what you're going to need to know is your x coordinate will be negative, your y coordinate will be positive. It should turn out that way. If it doesn't, I'm going to be a little concerned here. So make sure I plotted this right. Yep, should be right. So here we go. Convert to xy. We got r equals, keep doing that. X equals r cosine theta. Let's just go right to it. So -6 cosine of negative pi force. Let's use parentheses there. And your y coordinate will be -6 times the sine, negative pi force. Right. My next move, well, we know pi force is 45 degrees, so I'm going to take one step and actually write that. We got -6 cosine -45 and -6 sine -45. All right, -45 degrees, it's not going to tax our brains too much. That's a -45 degree angle. It has a reference of +45, but you are in quadrant 4. Again, 2 bits of information you got to know. Not just the reference angle, but what quadrant you're located in. So what I would say is this is -6, starting off with the r. Cosine of -45 should be the same thing as the cosine of 45, except you're in quadrant 4. In quadrant 4, cosine is positive in Q4. Q4. All right. Sine, however, so you could say this is just the same thing as the sine of 45. Sine, however, is negative in quadrant 4. All right, cosine of 45. If you remember from last chapter, that's going to be the square root of 2 over 2. And negative sine of 45 will be negative square root 2 over 2. Which gives me 2 goes into 6 3 times. We got -3 square root 2. And 2 goes into -6, -3 times. -3 times -3 square root of 2 is +3 square root of 2. So as we thought, we are in quadrant 2. That's a negative x coordinate and a positive y coordinate, 3 square root 2. And there you go. And that will produce that same polar coordinate. All right, let's see if we can't sneak in one more. Now, let me break my back. Number 4. Can you see down there? Yeah, you can. All right, just a special one. I already gave it away. But we say 7, comma, negative pi. All right, so 7, comma, negative pi. That's my polar coordinate. I want to go to rectangular, so let's get right to it. Your x is your r times the cosine, negative pi. Your y is your r times the sine, negative pi. Right, well, pi is 180 degrees, so we're looking at 7 cosine negative 180 and 7, sine. Okay, that's great. Sine of negative 180. All right, we do not have reference angles here. These are called quadrantal angles, and you know quadrantal angles do not have reference angles. How do we handle these? Well, we handle these the same way we did in the last chapter. I suggest you draw graphs. Now, if you say, nah, I got to do that, well, then you better start memorizing a whole bunch of quadrantal values here. So I'm going to draw a graph. Sine and cosine. Let's start with cosine. Now this time I'm going to need negative 180 for cosine. So I'm going to actually need the stuff back here. Then we can do the positive, that's no problem, but I really don't need this direction. I need the negative pi. That should tell the tale. So how does cosine work? You know how cosine works. That's not the graph, part of the graph I need. This is what I need. So what's the cosine of negative 180? Well, there's negative pi. It looks to be negative 1. So that's 7 multiplied by negative 1. How about the sine of negative 180? I don't know how well this is going to work. Let's give it a try. Sine starts off there, and I'm just going to go backwards. Sine would climb as its next move, so it should fall there, etc. And there. So let me dot it so it doesn't look too terrible. All right, that would be sine. Sine of negative pi looks to be 0, so we're going to say 7 times 0. You're looking at an x-coordinate of negative 7, a y-coordinate of 0. In other words, 7 negative pi would correspond to the ordered pair negative 7, comma 0. All right, next video, we'll talk about going from rectangular back to polar.